You need that from yesterday. Yeah, let me grab that for you. All right. So like I said, we're going to use trig functions today on the unit circle. We're going to work our way through that. We're going to add something in that's called a periodic function, which I'll explain a little later. Here is, I'll give you a quick heads up. You could have Googled this if you wanted to just kind of double check your answer key, but I'll give you a minute or two here to just kind of check, because if your unit circle is off, then obviously some of your answers then using the unit circle will be off. So you may want to just double check the degree measures, the correct radian measures, and then the coordinates in particular. Okay, so I'll give you a second to take a look at that. And then we'll talk about just a couple of patterns here again, just to kind of revisit some things. Yeah, pi is right here, but this is 180, yeah. This is 90 degrees. 270 is down here. All right, so if we take a look, a couple of things just as a reminder, heads up, some of those things again, just to kind of revisit the unit circle again. First off, if you're looking at all the coordinates, what are all of the x coordinates? Sine or cosine? Cosine. So if you think about it, all of the x coordinates of these points are the cosine of that angle. Okay? So for example, the square root of 3 over 2 is the cosine of 30 degrees, or the cosine of pi over 6 if you're in radians. Okay? What are all the y coordinates? Those are all the values of sine. Yep, those are your sine values. Okay? Sine of theta. And you're going to see in a second as we go through some more examples and stuff, everything you do with trigonometry comes from sine and cosine. That's why we focus on those two the most. Tangent, cosecant, all those other ones are all coming from sine and cosine. So those are the two most important ones that we talk about. Now, one of the patterns on your unit circle, again, if you had a chance to finish this up and you were able to kind of work with it and work through the assignment, now let me revisit some stuff that we talked about yesterday, but it might make more sense now that you've had a chance to work with it a little bit. Okay? So first off, there are two patterns on the unit circle. Every 30 degrees is pi over 6. Every 30 degrees is just another pi over 6 radians. Okay? And again, I mentioned this yesterday, but let me revisit it again because it may make more sense today. So if you notice, 30 degrees is pi over 6. 1 pi over 6. Then you go another 30 degrees. You're at 60. Now you're at 2 pi over 6, which 2 6 reduces to 1/3. That's why it's pi over 3. Okay? Then you go another 30 degrees, and you're at 3/6 pi. Well, 3/6 reduces to 1/2. That's why it's pi over 2. And you just keep going. Here's 4 pi over 6. Here's 5 pi over 6. Here's 6 pi over 6. So if you look at every 30 degrees as just another pi over 6, and then reduce the fraction, you'll have your radian measure. Okay? That's one pattern. You've got every 30 degrees being one pattern. The other pattern is every 45 degrees is another pi over 4. Every 45 degrees is another pi over 4. Same idea, just a different denominator. So if you take a look, 45 degrees is pi over 4. If you add another 45, you're at 90. So you're at 2 pi over 4, which is 1/2. 3 pi over 4. 4 pi over 4 is just pi. 5 pi over 4. 6 pi over 4. 7 pi over 4. Those are your two patterns in the unit circle. 30 degrees and 45 degrees. Those are the ones that you have to be able to be aware of. Okay? So just kind of, like I said, kind of revisiting that. We're going to keep working on this. We're going to keep using the unit circle. This isn't going anywhere anytime soon. Okay? So you just happen to be at the beginning stages of getting used to using it and understanding it. Okay? So we'll keep working on it. Before I go to anything else, does anybody have any questions? Just as I've got the unit circle up here in general of anything you don't understand, anything that you want to go over before we do start moving on. Okay, then any questions from the assignment? Let me start there. Anything from the assignment that you want to go over? Any problems you got stuck on? I mean, you can always come in during ELT as well if you don't want to do it as a whole class, but anything from the assignment that you got stuck on? Okay, then let's take a look. Let's go to the lesson. And like I said, there's not a lot of new stuff today, which is kind of nice. But here's example number 1 in your lesson. Well, this is almost like a warm-up type of problem. So given this unit circle, okay, granted, -4/5 and -3/5 are not points on the unit circle like the nice values, but they are on a unit circle. Okay, so given that picture, we're going to find the 6 trig functions of that angle t. We're going to find the sine of t, cosine, all that kind of stuff. All right, so like I said, even though these points are not on the unit circle that we were building, this is on a unit circle, okay, in general. So you can still think of it the exact same way. Meaning, if I ask you for the sine of t based on that picture, what would you tell me? What's the sine? What is it? It's the y coordinate. Just like it would be just like if you had sine of 30 degrees, sine of 120 degrees. In this case, the sine of t is still the y coordinate. It is -3/5. Okay? That's the sine of whatever that angle is, angle t. What's the cosine of t? It's the x coordinate. Okay? -4/5. Okay? There's the cosine of angle t. It is the x coordinate. How do I find the tangent of t? What do? By definition, tangent is sine divided by cosine. So we need to take these two answers and divide them. Okay? So if we do that off to the side, we have -3/5 divided by -4/5. And when you're dealing with fractions, what do you do when you divide by a fraction? Yeah. Rather than divide by -4/5, I'm going to multiply by -5/4. Multiply by the reciprocal. Dividing by -4/5 is the same thing as multiplying by -5/4. The nice part here is this cleans up pretty quickly. 2 negatives make a positive, so those go away. The 5s cancel each other out, and you're left with 3 on top and 4 on the bottom. Your answer is 3/4. Okay. The tangent of t Sine divided by cosine ends up being a positive 3/4. Okay. There's your first three functions. Now we got to go to the other three. Okay, the ones that we introduced yesterday, the secant, the cosecant, the cotangent, those three. The good news is, remember, those are just your reciprocal functions. So all you're going to end up having to do is take the reciprocal of the three you just found. Quick question. Which one is the reciprocal of sine? Is it secant or cosecant? It is cosecant. Okay? Cosecant of t. Therefore, negative 5/3. All you got to do is take the reciprocal. Here's my really great way, and I say great, I put that in quotes. Here's my really great way of remembering which one's the reciprocal of the other. You would think that since cosecant starts with a c, it would go with cosine, but it doesn't. It's the other one. Really great, right? I know, mind-blowing, is it not? You would think that secant starts with an s, so it would go with sine. No, it doesn't. It's the other one. Okay? I told you it's great. It's stupid. The more stupid, the better you'll remember it. Okay? So, secant of t is the reciprocal of cosine. So all we have to do is take negative 5/4. And cotangent is just the reciprocal of tangent. So all we have to do is take 4/3. Like I said before, all 6 of these answers came from which two? Sine and cosine. Once you had sine and cosine, you use those to get the rest of these answers. That's where tangent came from. That's where all the other reciprocal ones came from. Okay? So again, sine and cosine are always your two most important. Those are the ones we're going to focus on. Okay? All right. Here we go. Here's kind of the one slide where we've got, here's the new information for today. Okay? Put together in one slide. So if we take a look, domain and range here when we're dealing with sine and cosine. So the domain for sine and cosine is all real numbers. What that means is we can take the sine and cosine of any angle. If you think about the unit circle, we can go 0 to 360. We could keep going. We could take the sine of 1,000 if we wanted to, 1,000 degrees. Just happens to be that you're around the unit circle more than once. We could go in the negative direction. We can take the cosine of negative 30 degrees. We can take the sine or cosine of any angle measure. And because of that idea of the unit circle going in circles, it just keeps going forever and ever and ever, okay, in both directions. The range, however, when you do take the sine or cosine of an angle measure, the range, because of the unit circle, is always between -1 and 1. Okay? If you've got a radius of 1, the greatest value you can ever have is +1. The lowest value you can ever have is -1. Okay? And that goes back to that unit circle concept. Okay? That you've got a unit circle with a radius of 1. So +1 and -1 is where all of those answers should fall between. Okay? If you notice, by the way, and granted, like square root of 2/2, you probably don't know what that is as a decimal, but it's between -1 and 1 if you typed it into the calculator. Okay? 1/2 was another one of those main values that came on was on the unit circle, between -1 and 1. Okay? Same thing with square root of 3/2. If you type that in, the answer is between -1 and 1. Okay? So what we're going to do today, the one thing we're going to add to this is, for one revolution, if I work my way around the unit circle, okay, we have an interval anywhere between, if you're in radians, 0 to 2 pi, or if you're in degrees, 0 to 360. Okay? One time around the unit circle. But you could have multiple positive or negative angles of 2 pi, or 360, and I'll talk about that in a second. what I'm getting at is we're trying to figure out the location on the unit circle. Where do I end up? If you remember back to that concept of coterminal angles, where we said if I had a 30-degree angle, I could find another angle that would end up in the exact same spot, either going the other direction or by adding a whole nother 360. Okay, I'll come back to this slide in just a second. But here's what I'm referring to. Here's the idea. If I start here, and let's say I talked about 30 degrees. Okay, we end up at pi over 6. What if I asked you where would we end up on our unit circle if I went 390 degrees? It's the same spot, right? Because you would go a positive 360 plus the 30. You'd end up in the exact same spot. That's what I'm talking about when I say you can add 2 pi or 360 and that coterminal. I could add another 360 and end up in the same spot. And another 360 and end up in the same spot. That's what I'm referring to when I talk about you could have multiples of 2 pi or 360. Okay? You could go around the circle over and over and over again. Okay? And therefore, what ends up happening, and I'll go back to the unit circle here again. This is kind of the mathematical notation that they use. The sine of 390, like we just talked about, and the sine of 30 are going to be exactly the same because you ended up in the same spot. Okay? And like I said, I'll go back to the unit circle so you can see it in a second. When it says n is any integer, all n is representing is how many times have you gone around the unit circle. Okay? How many revolutions have you done? T being a real number, they're just saying whatever angle. All right, so let me kind of show you what this means. Let me go back to our unit circle here for a second and actually show you what I'm referring to when I say this information. Okay? And again, I'll come back. So I said before 30 degrees. If I asked you what the sine of 30 degrees is, what would you tell me? What's the sine of 30? 1/2. Okay, it's right here. 1/2 sine of 30 degrees. Now, here's what this is saying. What if I asked you what's the sine of 390 degrees? Same thing. The only difference is I went all the way around the circle and then 30 degrees. Either way, I ended up in the same exact spot. I don't care that I went around the circle the whole time and then plus the 30 degrees. That is what this is saying. If you take the sine of 30 degrees and then add 360 or 720 or whatever in degrees or a multiple of 2 pi, it doesn't matter how many times you go around the circle. All that really matters is where you end up. The sine of the first one will be the same thing as the sine if you went around 1 plus that, or 2 times plus that. Okay? That's what this is getting at. And the idea behind this, the terminology is that is what is called a periodic function. Okay? So kind of 2 different ways to explain it. That repetitive or cyclic manner is what is called periodic. Okay? And periodic means that a function has a repeated pattern, where you can go around the circle, and then again, and again, and again, and still get the same answers over and over and over again. That is called a periodic function. And the period of both sine and cosine is 2 pi or 360 degrees. You go all the way around the circle, and then everything starts over again. Then you get all the same values again, and then again, and then again. So the period is, it takes 360 degrees for the pattern to repeat, or 2 pi. Eventually, by the way, just to kind of give you a heads up, we're going to go from the unit circle, and we're going to take our unit circle, and that's where those sine and cosine waves are coming from. And hopefully you can kind of see the repeated pattern there as well. You've got a sine wave that kind of goes back up and down, and then it would go again and again, and would continue that wave pattern. Same thing with a cosine. That's where we're headed eventually. Okay? We're not there yet, but that's where we're headed, and that's how this is relating. Okay? All right. So let me give you some examples here. Let me give you an example of what I'm talking about. So let's say theta is 450 degrees. I want to find the sine of 450, the cosine of 450, and the tangent of 450. And the problem is, there's no 450 on your unit circle. But, Preston, what did you just say? 450 degrees, let me go through over here, is really 360 plus another 90. So I don't care so much about the first 360 degrees. This is the exact same thing as if theta was 90 degrees. Okay? The first circle, okay, great. But it doesn't do anything other than I just went in a circle and I'm right back to where I started again. All I care about is where I ended up. In this case, it's the last 90. And the coordinates of that point are 0, 1, which means, what's the sine of 450 degrees? 1. It's the same thing as the sine of 90. Those are the same. Okay? Those are coterminal angles. So this is 1. What's the cosine of 450 degrees? The same as the cosine of 90 degrees, which is 0. And based on those two, what's the tangent? Undefined, because it's sine divided by cosine, can't divide by 0. So tangent of 450 or 90 is undefined. Okay. Now let me stop for a second, because obviously we had a lot of terminology and all that kind of stuff that gets a little bit confusing. Make a little bit more sense now that you see it? Okay. Like I said, I don't care so much about how many times I'm going around the circle. What I care about is where do we end up. Okay? Let me give you a few more. We'll go to radians now and think of it this way. Give you a couple more practice problems here. So evaluate using the period as an aid, knowing that 2 pi is your period for sine and cosine. And like I said, we're trying to think coterminal. Where would I end up? Anybody tell me what the cosine of 3 pi is the same as? Cosine of pi. Cosine of 3 pi and cosine of pi are going to be the same. Here's why. I'll draw a quick picture off to the side so you can see it. 3 pi. If I start here, I go all the way around. How far have I gone? 2 pi, right? Full revolution is 2 pi plus another pi. Therefore, you end up in the exact same spot. We went all the way around plus another pi. I don't care about the all the way around. All I care about is the last part of it. Okay? Which means our coordinates right here are at -1, 0. Which means what's the cosine of 3 pi?
0. -1.
Thank you. -1. The cosine of 3 pi is -1. The cosine of pi is -1. Let's see if it's making sense. The cosine of what other angle would also be -1? 7 pi, 5 pi, 9 pi. All I'm doing is if I keep adding 2 pi, every time it comes back to the same spot again. We end up in the same spot just multiple times around the circle. Okay? Let me give you another one. This one's a little bit messier, but we'll clean it up pretty quickly. So again, you don't have a 9 pi over 4 on your unit circle. What I want you to think about is this. 9/4 is what as a mixed fraction? 2 1/4, right? Okay, 4 goes into 9 2 times, plus you got 1/4 left over. So this is the same thing as 2 1/4 pi, right? Which means, if this is making sense, do I care about the first 2 pi? No, it puts me right back at the same starting point. So this is really the same thing as the sine of pi over 4, or 45 degrees. Because 2 1/4 pi is 2 pi all the way around, plus another fourth, another pi over 4. What's the sine of pi over 4? That is on the unit circle, and it's square root of 2 over 2. Okay. So the sine of 9 pi over 4 is really 1 full revolution plus another pi over 4. The 1 revolution just starts it over, and then we have the extra. Okay. Let me do one more. This one's a little bit different because now we've got a negative rotation. Makes it a little bit more complicated when it's a negative. But I'll show you how you can use your unit circle to help you. All right, so I'm going to start in the same spot. Negative 8/3 is what as a mixed number? Negative 2 2/3. Okay, so this is really the cosine of negative 2 2/3 pi. Which once again, do I really care about the first negative 2 pi? So we can kind of get rid of that. I don't care about that first full rotation. This is really asking me, what's the cosine of negative 2 pi over 3? Okay. Which is still complicated enough because of the negative, but let me go to the unit circle and show you how you can use this to come up with it. Okay? Let me go back to the unit circle. Let me get rid of this for a second. So the problem here said the cosine of negative 8/3, which is negative 2 2/3 pi. Okay? Let's say it was positive first. We would start, go all the way around 2 pi plus another 2 pi over 3, which means we would have done this all the way around and ended up over here. But I went in the opposite direction. Okay? But if you think in the positive direction first, it makes the negative direction easier. That's why I'm telling you that. Okay? I don't really care about this. All I need to look at is I would go this direction. There's negative 2 pi. And there's the extra right there. Again, I don't care about this part of it. That just got me back to the beginning. Positive 120, we just went a negative 120. Here's the ordered pair that you're looking at. Okay? Positive 120, you got to go just the opposite direction, but the same amount. Negative 2 pi over 3 is a negative 120 degrees. Okay? And therefore, I asked you for the cosine. What's the cosine? Yeah. Ultimately, the whole point of this is you're trying to figure out, where do I end up on this unit circle and how many times have I gone around? Okay? Where's my landing spot and what's the sine or cosine of that landing spot? Okay? That's what you're taking a look at. Oop, let me go back. So, this ends up being negative 1/2. Okay? That's a negative 1/2. Okay? Like I said, I know it's kind of complicated. It's one of those things you kind of just got to work through, and the more you work through it, hopefully the more it will make sense. And if it's not making sense, then that's where you need to come in and get some help and ask some questions. Okay? And make sure that we can get you there. Okay? That's by far the hardest part of today. Next part, take out your calculator. The rest of today is calculator stuff. Graphing calculator. All right. So when evaluating with a calculator, if you are in physics at all, I'm sure you've heard, when you're in physics, make sure you're in degree mode on your calculator. Because every angle that you take the sine, cosine, or tangent of is always some degree measure. Okay? Sine of 30, sine of 50, whatever it is. Not always in pre-calc will you be in radians, but sometimes you will be. So, step number one is you got to make sure you go back and forth between radians and degrees when necessary. Okay? Here's how you do it. If you look on your calculator, there's a mode button at the top. It's right next to the second button. And I believe it's the third one down. Third or fourth, one of those two. Third one. If you take a look, third one down says radians or degrees. Right now I'm in degree mode. If I want to switch to radians, I arrow down and hit enter. And now it switches it to radians. Mode button is right next to your second button at the top. Okay? Now, be careful. This is one thing you got to remember. If you are in physics, when you go to physics, you need to change it back to degree mode. Otherwise, if you type in like the sine of 30 and you're thinking 30 degrees, but you're in radian mode, the calculator is actually doing the sine of 30 radians, not 30 degrees. So you got to be careful when you're back and forth between physics and pre-calc. Okay? Just a heads up. This is a routine you're going to have to start getting into of switching back and forth depending on what you're working on. Okay? So that's number one. Number two is there is no cosecant button. There is no cotangent button on your calculator. So I'll show you two different ways on how you can type that in. You can pick the way that makes the most sense and go with it. Okay? One of the buttons that is on the calculator that could help you, there's this x to the -1 button, which is right below the math button on the left-hand side. It's the fourth one down. Think about it for a second. Just think about exponents. What's a -1 exponent do? Puts it in the denominator, right? So if I were to take the sine to the -1, it's just going to drop the sine to the denominator, which is your cosecant. Okay? It's the reciprocal. Now, you don't have to do it that way. I'll show you two ways, and you go with what makes sense. Okay? Let me give you an example. Oops. Example number one. If I wanted to find out what the cotangent of 1 is. First question. When I say cotangent of 1, am I talking about radians or degrees? There's a simple answer. It is radians. Why? Simple reason. There's no degree symbol. If it's in degrees, it'll have a degree symbol. If it doesn't, it's radians. Okay? That's the simplest way that I can give you anytime if you're wondering, is something in degrees or radians? If it's in degrees, it will have a degree symbol. Okay? So this, I'm asking you for the cotangent of 1 radian. So, cotangent is just the reciprocal of tangent. So we could type this in as 1 over the tangent of 1. Just type it in that way. Okay. 1 divided by the tangent of 1. Make sure you're in radian mode, because we are typing in radians. If I switch back for a second. So if you type it in, here's what you should get. Approximately 0.642 is the cotangent of 1 radian. I told you the other option, you could use that reciprocal button. You could type in just the tangent of 1 and raise it to that -1 power. That's the reciprocal of the tangent. Either way. Personally, I prefer the first method just because it makes more sense. It's the reciprocal, so I type it in as 1 over. If it was the reciprocal of sine, I'd type it in as 1 over sine. This is an option, though, just if it makes sense and you want to use it. Notice you do get the same answer. Okay? You could do the tangent to the -1 power, or sine, or whatever. Let me give you another one. Another one to type in. What did I say that was? 0.642?
Yes.
All right. Thank you. And how about this one? Cosecant of 2.3 radians. Cosecant. Did you use my stupid method?
Yes.
See, it's stupid, right? It works. It is. It's stupid. That's why it works. Cosecant is the reciprocal of sine. So this is really 1 over the sine of 2.3.
I know what it is.
And if you typed it in correctly, you should get approximately 1.341. 1.341, somewhere in that vicinity. Okay. Questions? Because, like I said, being in radian mode and understanding that there's no cotangent button or anything along those lines, more than half of your assignment is just calculator stuff, just practicing this. So more than half of your assignment is going to go very, very quickly, the second half. Let me give you the assignment, and I will give you some time to work then as well, and that way if you have questions before you leave, you can ask them. Quick heads up. The last section is the calculator problems, and it says in the directions, use the calculator. In the middle section here, do not use a calculator. That was the one where we were doing the period and the periodic idea of use your unit circle for that middle section. Okay? Use your unit circle. Do not use your calculator. Okay. All right. And like I said, you've got some time to at least get started. If you have any questions, I can come around and help you, and we'll go from there.